So it's very, very difficult when you're operating by yourself to make all of the tools sufficient to survive. And I think that there's some really important lessons. We've all gotten used to, in the modern world, collaborating and exchanging stuff. But unfortunately, I don't think that happens like it should in the QA domain. Okay, it happens in the code domain. A lot of us work for companies that are using massive amounts of open source software, but we're not using massive amounts of QA software. And so my vision is at a super high level, I want to do for testing what open source has already done for code, right? So right now in Sony products, about 80 to 90% of the code that goes into a Sony product is open source, okay? And unfortunately, maybe about 5% of the testing that goes into a product is open source, okay? And so I want to get that testing ratio up as well. So there are open source. So it's not 0%, right? Because there are things like Jenkins or LTP that are widespread use throughout the industry, and these are open source and they're a good start. But I still think that there's a lot of aspects of testing that are not shared between companies. And so I want to actually promote the sharing of automated CI components, artifacts, and results the way code is shared now. And that means we actually need to think about, well, how can we take the materials that we have and put them in a format that can be shared? And also, back up there, and also allow components to specialize. One of the problems is we're kind of operating under the alone premise, where every framework is trying to build all of the pieces itself. Now we've actually started to see a shift in that, right? So kernel CI doesn't do the basic board management; it uses Lava for that. And same thing with Fuego. So Fuego, I've actually consciously avoided trying to write a board control layer because I'd rather leverage someone else's. And so we'll talk more about that as we go along. But so here's some non-goals for today, just because of the amount of time we have. We're not going to finish any standards or APIs. Okay, we may discuss some concepts, but there's no way we're going to finish anything like that today. But we can get the conversation started on the areas that would be worthwhile to collaborate on. And the other non-goal is, if you hear of a really neat idea that's being implemented in some other test system, the goal is not to run home and implement it yourself in your own test system. Okay, that's the wrong approach. The goal is to see how can we modularize pieces so that we can leverage the work other people are doing. Okay, so that we can take, you don't have to take your entire system and make it usable by something else. But if you have something that's really interesting and unique, if you can find a way that is somehow accessible to other test frameworks, we can start the process of specializing and commoditizing the different pieces that are out there. So hopefully people can identify the kind of unique value in your own system and unique value in other people's systems, and start thinking about how we can share those. Okay, so more concretely, here's a list of stuff that I want Fuego users to be able to do, but I don't want to have to write. Okay, so I don't want to do email-based patch triggers. 0-day has some neat stuff there. I don't want to do provisioning. I'm sorry. I used to do provisioning at Sony, and I don't want to do it anymore. I'd rather just do LabGrid or Lava or something else. I don't want to do DUT control drivers. I'm happy to use someone else's. Centralized results repositories. Kernel CI does that really great. Distributed results visualization. So, but there's a couple of things that, in my opinion, not being familiar enough with everyone else's, I think Fuego has a decent repository of test definitions. I think we do some, our pass criteria, I think is pretty good. I don't know, maybe someone else has something that's better. And then a generalized output parsing system. So I'd like to focus in on the things from Fuego that I think would be valuable possibly to other projects, and then use things from other projects that I can. Again, I want my users to have all of this. I want the industry to have all of this. So problem statements. So where are we? Why are we here? Many aspects of QA are not shared, and nobody can do it all themselves. Tests are viewed as kind of secret sauce, right? If you look at, but this is the exact same mentality about tests that companies had 20 years ago about the system software, right? Nobody was running, well, at Sony, we had, I won't talk too much about Sony, but I think every company about 20 years ago was using a proprietary OS at least on their consumer electronics products. And if you look today, again, that's all changed. 90% of the code in almost every TV set is open source. But if you look at, of Samsung, LG, and Sony, they all produce TV sets. Which of these are using actual tests, vertical tests from another vendor? And the answer is pretty much zero, right? We're using a couple open source tests, but and which of these actually publish any of their tests? And that's probably less than zero. I mean, it doesn't even occur to Sony that we should take our QA materials and publish them. And that's something that we really need to change in the industry. So now we're going to slow down a little bit and talk, well, why is it that tests are not shared? And this is my ideas. I do want, this is kind of an awkward discussion format. It's kind of nicer to have a round table when you want to have discussion, but I hope that people will not just let me stand up and just project my ideas. These are some of the ideas why I think tests are not shared. If you have additional ideas that you want to throw in on any of the slides as we're discussing, please raise your hand or speak up. But I think one of the problems is there isn't a place to share tests, right? So what is the central repository in Linux for Linux tests? Well, the closest thing we've got are two projects, in my opinion. We've got LTP and we've got K-self-test. Okay, so and LTP is a long time running project, and so the question is, well, how come a lot of vertical tests haven't been added to that? How come there's not like USB testing in LTP, or HDMI testing, or something like that? And so we need to think about the reasons why we haven't been able to coalesce around a common repository for tests. Now there are some open source tests that are out there that are generalized. Cyclic tests, Syscaller, IOZone, LMbench. These are all generic tests, right? But one of the things you don't see on the list is you don't see hardware tests on the list. And I think there's a lot of reason for that because it involves lab-specific code, right? When a company like Sony has a really awesome setup for doing USB testing. Right? And USB testing is a hard problem because there's a lot of, how shall we put it, non-standard behavior in the devices and the hubs and the protocols and stuff. And so we have internally this big rig that does multiplexing between USB ports and stuff. And but it's a custom rig, right? And so how do you genericize that so that even if Sony wanted to publish its test to do USB testing, how would we do that? Right? There's no standard that it is conforming to, and so I'm sure that other companies are also testing the USB on their devices. They have to be, but what are they using? I don't even know. So also the hardware, the tests. Obviously, they're going to be customized to particular hardware or software configuration, right? So. Some of that is changing. So like TV sets, lately a lot of TV sets are now converting over to Android. And so Android has a test suite that goes along with it. And so a little bit of that vertical testing is now being consolidated. But that's only because, how can I say this nicely? Because a dominant player is kind of taking over. And it's coming from Google. Which is fine, but it's like, well, that doesn't solve my audio testing or my camera testing or all the other areas. And I don't know, is the Android test suite, is that open source? I don't even know if it is. But anyway,
Yes.
is it? Yes. Anyway. And then the biggest reason, in my opinion, is that the test definition, what actually kind of constitutes the metadata for a test, it's very heavily test framework dependent. Okay, so I mean, so I was joking the other day, until I actually took the test survey, my own test survey, I didn't realize how bad Fuego was. We have Bash, Python, JSON, and YAML in our test definition when I started kind of counting up. Now it turns out that each of those is used for a different kind of section. So we're using JSON for the pass criteria, and for the what we refer to as specs, but what is a variant? We're using YAML for when we bundle the test materials together, and we're using Python for charting and visualization, and we're using Bash, or actually just shell script fragments, for the test instructions. And so we have good reasons to be all over the map. But we are all over the map. And other people, like I know Jinja 2 is used by Lava in a bunch of places. I don't know if they're super consistent about it. But the question is, can that be rationalized? Can we somehow harmonize that stuff? So another problem that I think we have to overcome is specialization. And this is true of, okay, so I'm here as a representative of embedded Linux, and embedded has this problem that everybody's doing their own thing, their own kind of unique twist on stuff. And so the solutions get very, very specialized. And what that means is that it's hard to reuse them in another scenario. And I think the same is true of QA software. For the reasons on the previous page, you end up having custom solutions. And in order to make a test more usable by other parties, you have to generalize it. Well, but once it's generalized, it's not as kind of fit for purpose as it was before. And so the paradox, well, I've got the word paradox on this screen, is that you need to have generalized tests, but that can be customized for specific test scenarios. Okay, so trying to think off the top of my head an example of that, but I'll have to come back to it. But there are different ways to customize tests. Okay, so if you look at something like cyclic test, or LTP, LTP has tons and tons of tests, like 20,000 or something tests, but you don't want to run all of them, right? Because it turns out that a lot of them fail, and not because the test itself is broken, but just because it doesn't apply to your board or your file system or your kernel configuration or something like that. And so you want to have something like skip lists. You want to be able to customize the expected values that match your particular stack, your software under test stack. And you want to use command line options, variants, to control how the test operates that matches your thing. The other thing is you want to have localized results interpretation. And I have a whole slide on pass criteria. But, and then preferably, you're asking some poor QA engineer to go do all this stuff, all this customization. And that's the part where you're really kind of asking too much. It would be really nice to be able to do automatic customization and to, for example, you notice that none of the benchmarks in the industry produce pass-fail. Well, it's obvious why, because the number that the benchmark pops out is going to be unique, right? So if you look at something like IOZone, right, it produces a number at the end that says how many writes per second. Well, what's the right number? Well, it depends, right? Depends very heavily. What SD card are you using? Are you on flash media? Are you on rotating media? What's the speed of your CPU? So that kind of stuff has to be customized. So benchmarks never produce pass-fail. They just produce numbers.
There is a solution for that. There are MNTs from Melbourne, and you just say run it with this kernel version, and compare the results.
Well, right. So that's a case where you, well, I don't know. Is that customizing expected value?
Not really, but Compared to previous
Oh.
results.
Yeah. We should pass the mic around. We'll do that in the future. So previous result, right? So the classic thing, right, is for a lot of this stuff on a benchmark, you run it once and you kind of declare mentally, oh, well, that's what it should be. I hope it doesn't change from that. And if it changes from that, then you say, okay, well, that's a regression. Well, maybe if it goes up, maybe it's not a regression. Maybe you're happy. But that's how a lot of this stuff is done. Is what you and in a way, what you're doing is you're customizing the expected result, right? So if last time I ran IOZone, I got 1,000, and this time then I set my expected result at 1,000 or 1,000 plus minus 5% or something like that. And then, but I had to choose that myself, right? And that's my thing. It's like as a QA engineer, do I have to go through for 100 benchmarks and go choose the expected value? That's like kind of an onerous task.
Each test case can have its own.
Yeah.
In that case, each test case can have its own validation criteria, like based on benchmarks, as you said, right? So depends on the card or interface, the numbers will vary. So the validation script will have the information. So based on the test it is running, it will go and check the log and see what exactly it ran, and it can define the criteria.
I don't need it. Yeah, that's right. So you have this notion of pass criteria, right? That my argument is it has to be customizable, right, for certain situations. And in particular, particularly for benchmarks very rarely come from the factory with the pass criteria. Right, that is something that's determined by the end user, and I think we'll talk more about that when we get. Hopefully, we'll talk about pass criteria today. Okay, another thing that is a problem when I started looking at harmonizing the work of different test frameworks is this factorization. What I'll call factorization. So different frameworks factor their data and services quite differently. In fact, it took me literally like a year to understand how kernel CI and Lava had factored their stuff, because it was just so different from the way that Fuego does it. And it comes down to kind of how the processes are broken apart, where the interfaces are between the processes and the services, who is responsible for actually performing a particular operation. So sometimes the test performs an operation that's expected to be done on target, or on the device under test. Sometimes the framework does it. Sometimes it's performed by an external service. Sometimes the end user is expected to do that operation. Okay, so like take an example of parsing, producing kind of a standardized result format, right? I'm going to speak up and I could be wrong. So I think the test itself, for the most part in Lava, is expected to call the shell, what is that, the Lava test shell, to produce a string that's recognized by Lava. And that string is the key that's in a known format to Lava that it can then put into the results database. Okay? And we do that totally differently in Fuego. We do it as a post-processing step. We take raw logs off the target and have a separate parser that's completely separate from the test itself. And so harmonizing those, because of that difference in factorization, is going to be difficult. Okay, we'll have to think of yeah. Oh. Okay.
Just a comment on the Lava side. So what you basically said is right, but when we run tests for LKFT, for example, we do exactly what you do, but on the target, and that's it. So
right, yeah.
We have our set of our shell scripts that post-process the results on a target.
Right. No, you're right. I knew that there was a parser inside Lava. I was oversimplifying. In fact, the fact that Lava had a parser that's what took me so long to figure out that you guys did it on the fly sometimes. Or actually I think most of the time. I don't know how often, or is it?
Most of the time not.
Oh, most of the time.
Yeah, because you would have to, this is I think
comes down to the talk that Tim gave at the conference. So you would have to customize your framework to output the proper string to do it on the fly.
Right.
So when the string outputs something else, you have to have a dictionary that matches
Right.
and converts it. So we don't want to depend with our tests on. So there were a lot of complaints from users that like the test can be only executed in Lava. So we came up with a solution that we have a shell script that executes the test and produces the results, and the same shell script can be executed in Lava, like with different parameter.
Okay.
Yeah.
But that's, so just to clarify though, that shell script wrapper that's on
That runs on target.
on that.
Yeah.
Okay.
Yeah, but
Yeah.
well, depends on the test. So for CTS, it runs on a host, but yeah, the concept is the same. So you
Right.
have a shell script that wraps around the test suite and then parses the results the test suite produces to the form that can be digested by Lava.
Right. Okay.
So I would say, I guess the same with Fuego, right?
Well, Fuego, we do as little as possible on target. So
Yeah, but like you have a wrapper around that digests the results that the test produces, and then you save the result in the form that you understand it, right?
yeah. Well,
So it's same
what we
concept.
do is we grab the raw log from the. We do a couple of things that are really different. Since we're talking about it, so what we do is we save the raw data from the test program on the target. Then after that test program is done and completed, we go over as a separate operation, pull it to the host, and then we parse it there, and then convert it into something we call the unified output format, which is actually as close as we thought we could get to the kernel CI format.
Yeah, so that's what I'm saying. So you get the raw output and parse it to the form that's digestible.
Right.
Yeah. So the set is the same concept, but it's in a different place.
Right. Yeah. Well, and that's exactly what we're talking about. Is like where it happens and like kind of whether it's synchronous or asynchronous. Those things are kind of, you have to think about how to match those. That's where the impedance mismatch is between the different systems. And then, so that's kind of the same thing. When the operations are performed, is it during the test? Is it during post-processing, synchronously, asynchronously? And then this is the one where I was going to save my Fuego example of our 4 different files for a test definition. So parts of the test definition are in different files. And the reason for that is that if you want to support customization, right, then things that you want to customize per board have to be kind of associated with the board file or the board definition. Things that you want to customize per test have to be associated with the test. So you end up, it starts to get kind of complicated, right? You have different pieces of metadata that are living in different parts of the system that you have to manage. And then we don't even have a per lab customization level, but I think that other systems do. So anyway, so factorization I think is one of the biggest hurdles to us kind of coming together and figuring out how to make things work together. Okay, now I'm going to go off on this is a weird mental tangent, and I'm not expecting this. I'm just dropping an idea in your head, and I'm going to let you think about this. So testing is by nature fractal oriented. So test features look the same at all kinds of different levels of resolution or levels of abstraction. So an individual test case, if you go into like abort 02 in LTP, right? It's got a bunch of assertions. It's doing some operations, and there's an expected value, and the test itself looks at in C code. It looks at that. It does a syscall, looks at the expected value, sees if it was what it was expecting, and then issues a pass or fail based on that. Okay? Well, if you go up a level to the suite of LTP tests, right, then there's a whole collection of these system call tests. And they are all producing results. And the collection of results now has kind of an expected value or expected set of values. So you've gone up a level. And then if you go beyond that, if I'm running LTP and K-self test and IO bench and a whole bunch of other tests, then for an entire kind of run of test suites, I've got a series of, again, values that have come back from the system that I have expected values for. It turns out that at each of those levels, the way that that expected value is expressed, you know, in this one it's usually in C code or Python code. At this one, it's usually done by a parser. At this one, a lot of times people aren't even aggregating. This one usually shows up in the visualization. You get these red-green things, but only after only after you've looked at them. A human has looked at it and said, well, this part failed, but this part succeeded. So you can do pass criteria, results analysis, and reporting at all levels, but for some reason, well, the features are expressed completely differently at those different levels. And so I don't have, this is not a problem statement, or even I don't have a solution or any kind of statement of, I just wanted to put that in your brain and plant a little seed and let you think about that, just because I'm evil.